So imagine trying to recreate your grandmother's incredibly delicate hand-pulled traditional halva.
Oh man, that is practically an art form.
Right. I mean, it relies almost entirely on tactile feedback. You have to know exactly when the sugar syrup has hit the perfect temperature.
Yeah, you literally have to feel it.
Exactly. You have to feel the resistance of the sesame paste as you fold it in by hand, making sure you don't break those delicate crystallized strands.
Which is incredibly stressful to do, even for one batch.
Right. So now imagine having to do it exactly the same way 10,000 times an hour.
Wow.
Using robotic arms and high pressure steam without totally ruining the texture.
That sounds completely impossible.
You would think so.
Yeah.
But today, for this deep dive, we have our hands on what looks like a totally boring corporate directory, but it's actually a blueprint for doing exactly that.
Yeah, we are looking at a website directory and a product catalog for this Turkish manufacturing company called Sefer Makina.
And at first glance, it's super dry.
It really is. It presents as this highly functional, entirely utilitarian document. It just outlines standard corporate foundations.
Right, like sections labeled Kurumsal, meaning corporate, Certificalar for certificates.
Referenzlar for references, and Carrier for career. It's exactly what you'd expect.
Yeah, and those sections are essentially the digital footprint of a massive, heavily vetted industrial player.
Right, they establish the baseline of a company operating on a global scale.
But the mission for us today is to look past those standard corporate headers. We really want to reverse engineer the core of this document, which is the Ürüngruplarya, or the product groups.
Because that's where the real story is.
Exactly. We're peeling back the layers of this super specific machinery catalog to reveal the staggering industrial engine that puts sweets on shelves all over the world.
And this product catalog provides the perfect causal narrative for that. To actually understand the sheer scale of the engineering hidden in this list, we have to start by analyzing what these machines are built to make.
Right, we're moving from the boardroom straight down onto the factory floor.
Exactly.
So looking at the specific food production machines mentioned in the source, we get this fascinating cross-section. The list includes, Cioccolata for chocolate and Kek for cake.
Which is pretty standard stuff.
Right. But right alongside those, we see Krokon, which is croquant or nut brittle lokum, widely known as Turkish delight, and Helva, or halva.
And that specific combination of products it reveals this distinct duality in their operation.
How so?
Well, they are clearly manufacturing the hardware for standard, universally ubiquitous snacks, right? Your basic chocolate and cake.
Yeah, the baseline expectations for any commercial confectionery supplier.
Exactly. But the real revelation is in that other half of the list. They are specifically mechanizing highly traditional, historically artisanal regional delicacies, but doing it at a massive industrial scale.
Okay, let's unpack this for a second. Looking at this list is kind of like looking at the blueprints for an international Willy Wonka factory.
That's actually a great way to put it.
Right. It's not just about making candy. It's about scaling up grandmother's traditional recipes into these massive automated outputs. Because mechanizing chocolate, that's a well-documented process.
Yeah, we understand tempering and enrobing. That's settled science.
But mechanizing something like halva, or Turkish delight, that introduces a totally different set of physics and chemistry problems.
Oh, absolutely. Just consider what goes into traditional halva production. It's basically this massive emulsion and crystallization challenge.
Right, because you're starting with tahini.
Exactly. You take tahini, which is this sesame paste with a super high oil content, and you mix it with a highly heated aerated sugar syrup.
Which sounds tricky enough on its own.
And it gets more complex. Traditionally, an artisan introduces an extract from soapwort root to create a foam structure in the sugar.
Wait, soapwort root?
Yeah, it's very traditional. But then comes the really critical phase, which is the kneading. The artisan has to gently fold the tahini into that aerated sugar.
And the folding technique is literally everything, right? If you mix it too aggressively, you introduce way too much shear force.
Exactly. You break the fragile sugar crystals, the oil completely separates from the sesame paste.
Oh, wow.
Yeah, and instead of this flaky, melt-in-your-mouth delicacy, you just end up with a dense, oily brick.
So translating that intuitive, highly tactile process into cold, hard, repeatable math, that has to be the crux of the engineering marvel here.
It really is. That's what's hidden in the Helva Üretim, the halva production machines they list. They can't just build a giant industrial blender.
Right, that would destroy it.
Exactly. They have to engineer these highly specialized planetary mixers with very specific blade geometries. These mechanical arms actually simulate a human fold.
That is wild.
And they require torque sensors that can detect the changing viscosity of the mixture in real time. They have to adjust the speed of the fold millisecond by millisecond so they don't break the emulsion.
Okay, and we see a totally similar physics hurdle with the Lokum, Üretim, Makine, right? The Turkish delight machines.
Oh, definitely.
Because Lokum is essentially a non-Newtonian fluid during its cooking phase. It's this incredibly delicate balance of starch, sugar, water, and citric acid, usually.
And the gelatinization of that starch is just notoriously finicky. It requires this sustained, perfectly even heat.
Right, because in an industrial setting, if the temperature in a, let's say, 500-liter cooking vat fluctuates by even a couple of degrees,
the starch just burns at the bottom.
Ugh, ruined batch.
Yeah, or it fails to set properly and you get this gelatinous soup instead of a firm, chewy cube.
So to fix that, these machines must incorporate, precision-engineered, jacketed cooking vessels.
Exactly. They use highly regulated steam pressure to ensure an absolutely uniform thermal distribution throughout the entire massive batch.
See, understanding those specific thermodynamic and kinetic hurdles, it totally shifts how you view a simple piece of brittle or a square of Turkish delight.
It really does. It's the physical manifestation of some incredibly complex problem solving.
But, mechanizing the recipe is really only half the battle. Because once you have a 500-pound vat of perfectly mixed, temperature-controlled Turkish delight, you face a brand new physics problem. How do you move a massive, sticky solid into individual wrappers before it sets?
Which is a complete logistical nightmare. And that actually brings us to the second half of this catalog.
Right, the supportive and final stage machinery listed in the Ürün Grupları section.
Let's look at how they solve that. The source lists this sequence of highly specialized equipment.
Yeah, we see Fıstık, Kavurma makineleri, which are net roasting machines.
And then there's the Ekstrüder bar Üretim Hassas, meaning extruder bar production lines.
Plus sıvı dolu makineleri, the liquid filling machines.
And finally, PLC'ler makineleri, which are the packaging machines.
So wait, looking at this list, from roasting nuts to liquid filling to packaging, could someone theoretically use this one catalog to build an entire factory from the raw ingredient to the plastic wrapper?
Yes. What the text outlines here is a complete turnkey industrial pipeline. It reveals that this company provides a total end-to-end ecosystem.
I mean, from a purely operational standpoint, purchasing an entire turnkey pipeline from one vendor sounds incredibly risky.
How so?
Well, in the tech sector, for example, a company usually diversifies its vendor stack, right? You buy your servers from one company, your networking gear from another, software from a third.
Right, to mitigate risk.
Exactly, because specialization supposedly yields better quality. So why would a factory manager risk buying their entire manufacturing pipeline from a single supplier? If one proprietary part breaks, doesn't the whole factory go offline?
The tech stack analogy is helpful, but industrial food manufacturing operates on a completely different fundamental principle, which is physical synchronization.
Okay, physical synchronization.
Yeah. In a digital network, data packets can just queue up if there's a bottleneck, right?
Right.
But in a factory producing highly volatile, temperature-sensitive food products, there is no queuing. You are dealing with a continuous flow of hot sugar and starch.
Oh, man. So if the product stops moving, it just hardens in the pipes and destroys the machinery.
Precisely. Let's actually trace a complex product through the machinery listed here. Say, a modern fusion product, like a chocolate-enrobed Turkish delight bar with a liquid caramel center and roasted pistachios.
Sounds delicious and incredibly complicated to make.
Very. According to the catalog, you start with the Fıstık Kavurma makineleri. The raw pistachios go into rotary drum roasters, and the roasting profile has to be exact.
Because of the moisture.
Yes. If the nut retains too much moisture, it will literally seep into the starch gel of the lokum, causing the bar to basically rot from the inside.
Ew, okay.
But if it is over-roasted and too dry, the brittle nut will actually fracture the metal blades of the extruder further down the line.
So the thermal sensors in the roaster have to be perfectly calibrated to the specific moisture tolerances of the lokum recipe that's being mixed in the other room.
Exactly. Then those perfectly roasted nuts are folded into the lokum mixture, which is fed into the extruder bar Üretim Hatam. Right. An extruder is a high-pressure system that forces this thick, highly viscous mixture through a specifically shaped die. The physics here are intense.
I bet.
The machine has to generate enough pressure to push a continuous ribbon of sticky starch and nuts, but not so much shear force that it actually crushes the pistachios.
And looking at the catalog, we are simultaneously integrating the sieve dolum macchinari, right? The liquid filling machines.
Yes, this is where we see co-extrusion. As the lokum is being forced through an outer annular die to film the shape of the bar, there's an inner pipe injecting a precise volume of liquid caramel directly into the center of that continuous ribbon.
That's crazy. And the flow rates of the thick lokum and the thinner caramel must have to match perfectly.
They absolutely have to.
Yeah.
If the liquid pump pulses even a fraction of a second too late, you get hollow bars.
Oh, and if it pumps too hard?
The caramel just blows right out the side of the lokum ribbon.
What a mess. So following the flow, that endless caramel-filled ribbon of lokum is then cooled, sliced, sent through the chocolato line for chocolate coating, and finally hits the pacchetame macchinari, the packaging machines.
Which brings us right back to your question about the risk of a single supplier turnkey system.
Right, the vendor lock-in.
Yeah. A high-speed flow wrapping machine takes a continuous sheet of plastic film, forms it around the incoming chocolate bars, and uses a rotary sealing jaw to crimp and cut the plastic between each bar at massive speeds.
So if the extruder is pushing out, say, 300 bars a minute, the rotary sealing jaw has to strike the gap between the bars 300 times a minute with literal millimeter precision.
Exactly. If the cooling tunnel belt slips by even 1%, or if the extruder pressure drops for just a microsecond, the spacing of the bars changes,
And then the packaging jaw strikes the actual chocolate-covered lokum instead of the empty wrapper.
resulting in a catastrophic sticky jam that shuts down the entire line.
Wow, okay, that answers the vendor lock-in question perfectly. By offering the complete line from roasting to packaging, Sefer Makina is implicitly guaranteeing the underlying software architecture.
Exactly. They are ensuring that the programmable logic controllers, the PLCs, inside every single machine speak the exact same protocol.
So the torque sensor on the extruder is literally communicating directly with the servo motors on the packaging jaw.
Yes, that synchronization eliminates the communication bottlenecks that you get when you try to integrate disparate machines from totally different manufacturers.
It's this intricate, highly calibrated ecosystem where heavy steel, high-pressure steam, and hot sugar are basically managed by unified code.
That's exactly what it is.
So establishing the massive scale and delicate synchronization of this physical machinery forces us to pivot to the final layer of this document.
The logistics.
Right, because designing and building a turnkey co-extrusion factory is an incredible feat of engineering. But how does a company actually support this kind of heavy, complex hardware once it leaves their own facility?
This is where we move from the physical mechanics to the logistical infrastructure, which is totally detailed in the source's contact and corporate sections.
Yeah, let's look at that. The source provides several highly specific communication pathways. They list a dedicated phone number, 444-7881-MEND.
Right.
They provide a direct email, info@sefermakina.com.tr. There is explicitly a WhatsApp integration mentioned. And if you look really closely at the language toggles hinted at in the text, you see TR, EN, FR, AR, which is Turkish, English, French, and Arabic.
And the most critical piece of evidence regarding their operational scope is this direct quote about their technical service. The text explicitly promises "Dinangen her yerinde satış sonrası teknik destek."
Translating that for you listening, worldwide after-sales technical support from an experienced and expert staff.
That explicit guarantee of worldwide technical support combined with those specific language codes defines their entire market footprint.
Meaning this equipment is being exported globally.
Absolutely. The inclusion of French and Arabic, alongside English and Turkish, points strongly toward the Middle East and North Africa. Those regions represent massive consumer markets for traditional confections like lokum and halva.
Okay, here's where it gets really interesting. The technical support guarantee totally reframes the entire business model. Buying an industrial extruder line isn't just a transactional purchase. It's a marriage. It's a long-term operational partnership.
Like buying a commercial jet.
Exactly. The aftercare, the WhatsApp troubleshooting, the global tech support, that is just as vital to the factory manager as the physical steel of the machine itself.
Because industrial food machinery is subjected to some of the harshest operating conditions imaginable.
I can't even imagine.
It faces high heat, immense pressure, continuous friction, and the corrosive nature of acidic food ingredients or really caustic cleaning chemicals. And it's often running 24 hours a day.
So things are definitely going to break.
Constantly. Bearings wear out. Pneumatic valves get stuck. PLC sensors drift out of calibration.
And when a fully synchronized turnkey pipeline goes down because, say, a single sensor fails on the liquid filling machine, the factory is losing massive amounts of money for every single hour they aren't producing.
Right, because they can't just bypass the filler. The entire co-extrusion process just halts.
So offering worldwide after-sales technical support means this company must maintain an incredibly robust logistical backend to mitigate that downtime.
They have to possess the capability to troubleshoot a complex automation failure anywhere on the planet, almost instantaneously.
Which perfectly contextualizes that WhatsApp integration mentioned in the directory. I mean, think about a factory floor in Morocco or Algeria at 3 a.m. It's a chaotic environment.
Very chaotic.
If an extruder starts throwing pressure errors, the local floor manager is going to go sit down, draft a formal email, or wait for a regional sales rep to visit.
No, of course not. It functions essentially like telemetry in Formula One racing.
Oh, where the engineers at the factory are diagnosing engine anomalies on a car racing in a totally different country in real time.
Exactly that. The local operator can just use WhatsApp to send a quick video of a mechanical binding or snap a photo of the diagnostic codes straight from the machine's control panel.
And then the engineering team back in Turkey can immediately triage the issue.
Right. They might remotely adjust the steam pressure limits via a secure data link or immediately dispatch highly specific replacement parts from a regional hub.
So they are engineering massive mechanical solutions in Turkey, exporting that heavy machinery across continents, and maintaining this constant digital diagnostic link to keep the global supply of these highly specific suites flowing.
It is a staggering level of coordination, all hidden behind a few simple icons on a corporate webpage.
It's wild. We started today with what looked like the most mundane document possible, a simple directory and product list.
But by unpacking the specific engineering challenges implied by those product groups, we uncovered a comprehensive global operation.
Yeah, we analyze how they take raw agricultural products like pistachios, combine them with the complex chemistry and the required physical intuition of artisanal recipes like Lokum and Helva.
And then engineer mechanical arms and extruders to perfectly replicate that intuition for worldwide mass consumption.
Furthermore, we explored the necessity of the turnkey ecosystem required to do that safely and efficiently.
We saw how an integrated end-to-end pipeline totally relies on unified software to synchronize everything from the roaster all the way to the high-speed wrapper.
All supported globally by a dedicated, multilingual technical infrastructure.
It's incredible.
You know, understanding the physics of extrusion and the necessity of PLC synchronization completely changes the context of the snacks sitting in your pantry right now.
It really should.
Yeah.
Every perfectly uniform chocolate-enrobed candy bar and every identically textured slice of packaged halva you consume is the direct result of this exact type of massive, coordinated industrial engineering.
It is a continuous triumph of mechanical precision over the chaotic, constantly shifting variables of agricultural ingredients and thermodynamics.
Absolutely.
So as we wrap up this deep dive, just consider the scope of what we just explored. The next time you are in your own kitchen and you are struggling to recreate a delicate family recipe, maybe the dough temperature drops too quickly or the sugar crystallizes just a little too aggressively.
Which happens to all of us.
Right. And you just cannot achieve the exact texture your grandmother managed with just a wooden spoon and an intuitive feel. I want you to imagine the sheer mathematical genius required to program a machine to navigate those exact same physical hurdles.
Tens of thousands of times an hour.
Exactly. Flawlessly on the other side of the globe. Suddenly, that generic list of corporate machinery isn't just a directory anymore.
It's the blueprint for translating human intuition into an industrial marvel.